Okay, so we are going to finish up yesterday's stuff, and we're going to start by doing a warm-up to prove that this is a parallelogram. So remember from yesterday, you need to prove that BC is parallel to AD, but you also need to prove that AB is parallel to DC. So you need to find the slopes of each of those lines and prove that they're the same. So take a couple of minutes and work on finding those slopes. All right, so we're moving into the second half of the slopes and parallel lines, and part of that is using a slope to find a missing vertice, to be able to say, how should this figure look, and how would we use slope to find that? So here's an example of what I'm talking about down here at the bottom. We have 3 of the vertices, but we're missing something in this area that would make this be a figure. So the first thing you have to do is you have to find the slope of the line that's going to be the same part of the line on the figure. So because BA is going to be related to this side here, we have to find the slope of BA. So I'm going to pull up this other screen so that we can find the slope of this line right here. And again, the first thing that we need to do is we need to identify what the points are. So B is going to be over -2 and up 3. And A is going to be over 1 and down 2 in the negative direction. So I'm going to just put them over here. Let me zoom out just a little bit. B is -2, 3. A is 1, -2. We're going to call this x1, y1. We're going to call this x2, y2. Again, if you do not remember our formula and you have not written it down yet, you're crazy. Just get it written down. You're going to use it a ton, all right? So hopefully you won't even need to have a note by the time we get to proficiency. You'll just have it memorized. So anyway, we're going to do, let me change colors. We are going to do y2 minus y1 over x2 minus x1. I have -2 minus 3 is -5. I have 1 plus 2, which is 3. And that can't be simplified. And so we are going to use that as our slope. So if you look back at this, we found our slope. Now we're going to start at D, and we're going to count the same number of units that it's going to take for us to get there. So the one thing you have to remember is that this movement right here is your rise, okay? And this is your run. But it could also go the other direction. You could say that this is 5 over -3. And for what we're going to do, we're going to use it in this manner because it makes the most sense to get up here. We're going to go down 5 over 3. We're going to be over here, and we need to be up here in this area. So we're going to go up 5. 1, 2, 3, 4, 5. And we're going to go over 3 in the negative direction. And this is point C so that we can finish our figure. Okay? So again, you might have to tweak your slopes at the very end to be able to make it fit where your point needs to go. So the last step is to prove that where you just put that makes there be parallel lines. What that means is we need to prove that this line and this line are parallel. We know that these 2 lines are because we just made them be because of that. So the last thing we have to do is figure out if the last 2 are going to be. So C landed at the point 2, 4, and D is at the point 5, -1. So we're going to get going on. C is 2, 4. D is 5, -1. We're going to call it x1, y1. Whoop, 1, 1. x2, y2. And we're going to use our formula, y2 minus y1 over x2 minus x1, and we end up with -5 over 3, which means that they are parallel and we are good. Okay? So I know that is a lot, and hopefully you're taking notes and writing down step by step what you have to do. We're going to try this again for another one, okay? And this one you'll notice is not graphed for us, so we're going to start by graphing, okay? That's going to be the first thing that we do. So let me pull up this, and I'm going to use a different color. Let's use orange. All right, so point P is going to be -3, 0. So right there is going to be point P. Point Q is -2, 4. So -2, and then up here 2, 4 is point Q. Point R is 2, 2. So over 2 and up 2. So now we know we're going to end up with some number down here. Okay, that's the only way we're going to be able to get a 4-sided quadrilateral, is somewhere down in this area is where we have to be. Okay, so we know that that side goes like that. So we are going to figure out what this side has to be, how we're going to go from R to somewhere that has that same slope. So we have to figure out what is the slope of PQ. We already know the points. P is -1, 3, so I'm going to call it x1, y1. Q is -2, 4. I keep calling that y2. Now we're going to do x2, y2. We're going to use our same formula. So we're going to say y2 minus y1 over x2 minus x1. And 4 minus 0 is 4. And 2 plus 3 is 1. So the slope is going to be 4, which means 4 in this direction and 1 in this direction. So because we need something down here, going up 4 and over 1 would get us over here. Okay, that's not going to help us. So what we need to do is we need to go down 4 and over 1, because a negative and a negative is a positive. So if I start here and I go down 1, 2, 3, 4 and over 1, that should give me point S. And now I can draw in my figure. Okay. And now we're going to have to figure out, is QR parallel to PS? That is the only part left to do. So again, we need to figure out what is the points of S. Well, over 1 down 2 is 1, -2. We have all the other points, right? Because we graphed them. So we're looking at PS. So P is -3, 0. S is 1, -2. X1, Y1. X2, Y2. Plugging it into our formula. -2 minus 0. 1 minus -3. 2, -2 minus 0 is -2. Over 2 equals -1. So now we're hoping that this QR is going to have the same slope. Let me change colors for us. So we're going to use Q, which is -2, 4, and R, which is 2, 2. We have X1 and Y1, X2 and Y2. So Y2 minus Y1 over X2 minus X1. Okay, so 2 minus 4 is -2. All right. Oh, I messed up on this first one. 1 plus 3 is 4. This should be a half. I was going to say, because this one's going to give me 4, which is a -1/2, and they have to be equal. So see, you can catch your own mistakes as you go through that too. I should have recognized that 1 plus 3 is 4. And when I got a 4 over here, I should have known I did something wrong there, because we need to prove parallel lines. And the only way you can do that is if your slopes are the same. So it's kind of nice to have like a check in there for you, so that you can kind of figure it out. If you're going along and you're way off, you know you did something wrong somewhere that you can fix. All right, I'm going to have you guys try one. You're going to practice with this. And the whole point of this, we have J, K, and M. So you're going to be looking for point L. Let me fix that and write that in here for you. Find L. Okay, find L. That is what we are missing. So let me make this a little bit bigger for you. You're going to want to start by graphing this, graphing your points so you can kind of figure out where L even has to go. You need to know what part of the graph it needs to go on. And then once you know that, you can start looking for L. So find what point L is and make sure to do your checks on your parallel slopes to make sure that it makes sense. All right, so I have a really quick question for you guys. We've been talking about finding how things are parallel or how things are a trapezoid. What would you do to prove that it is not something? Okay, well, you would take what it has to have and then you would make sure that it doesn't have that. So in order for something to be a trapezoid, it has to have a set of parallel lines. In order to prove something is not a trapezoid, you would have to prove that there are no lines that are parallel, which means AB is not parallel to DC or AD is not parallel to BC. So if you ever get a problem where it's asking you for like the converse, the other side of it, proving something is not something, you're going to do it the same way you would prove that something is, because getting two different slopes means it can't be. So it's not any different just because you see the not. You're still going to go about it the same way. You're still going to have to prove that you have parallel lines and parallel slopes to do it. Okay? All right, lastly, as you're going through this, the things you need to think about. This section is primarily about proving trapezoids because trapezoids have a set of parallel lines and parallelograms. We have not talked about squares and rectangles because that is going to be dealing with angles. And right now we're just talking about sides being parallel. This strategy is for not for angle measure, just side lengths. Okay, just sides, not angle measure. Tomorrow we will start talking about perpendicular slopes, and that does have to do with angle measure. So for this, what we're doing, everything we've been talking about is parallel, 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 and primarily for trapezoids and parallelograms. All right, you guys are going to finish the second question on the exit ticket that we started yesterday. So if you open it back up again, you should be able to resubmit your answer with number 2 now done in it. So by the end of the period today, you will have finished the exit ticket with both questions, and you do need to get both of them correct for credit. All right, like always, reach out if you have any questions. Have a fantastic day. Bye.